I hope you enjoyed using that online simulation to learn more about how resistors act when they're hooked up either in parallel or in series with one another. Today we're going to learn how to go about analyzing resistors in parallel and resistors in series mathematically. And we'll do that by looking at example 15.3. And the first part of that example they give us has two resistors in the same circuit, and they are hooked up in series. So what that means is that when the current starts to move around the circuit, it has to go through both resistors. It doesn't have any choice but to go through both of them. And so you can make an analogy there where you are traveling down the interstate, and then you get to one construction zone where they've narrowed the number of lanes down to maybe from 4 down to 2 lanes, and then it widens back out again, and then you get to another place where they're doing road construction again, and it's been narrowed again to maybe 1 or 2 lanes in place of 4 or 5 before it opens back up again. And so the way you can think about this then is that basically the current is going to get slowed down twice because of 2 places of road construction or 2 places of resistance. So how am I going to calculate then what the effective resistance is? Basically, the current's getting slowed down twice. It has no choice but to go through both of those resistors. And so the total time delay then is, if you were actually in a car driving through this, is going to be the delay you experience here plus the delay you experience here. And so it's going to be the same thing for resistors. So if you've got resistors hooked up in series, the effective resistance, which I am designating by a capital R with an EFF to stand for effective, is equal to resistance 1 plus resistance 2, and then on and on for however many resistances there are in the circuit. So for this particular one, my effective resistance is going to be 12 ohms plus 15 ohms, and there's only 2, so obviously that's as far as that's going to go. So then that tells me that my effective resistance is going to be 27 ohms. So if I wanted to redraw the circuit, what I could do is to redraw it with just one resistance like this and mark it as 27 ohms. Okay, so when they're hooked up in series, then they're just going to be added together. Now it's a little bit different in the second part of the problem, where I have 2 resistors that are hooked up in parallel to each other. The second part of the problem says, replace the 2 resistors in the circuit diagram below with an effective resistor. What is its resistance? So you'll see that the resistors in the second half of the problem are the same as in the first half of the problem, but they're now hooked up differently. And the difference here is that when the current goes around the circuit, it has a choice. It can either go this direction or it can go this direction. It's not going to go through both of them. It's only going to go through one. And so again, if you make an analogy to road construction, you realize there's road construction. There's going to be road construction either way that you go, but you can either choose this one or you can choose this one. Now think about the effect not only on your particular travel, but on all of the traffic altogether. So all of the traffic, it has to make a choice, and they may choose to go through one resistor or the other, but the overall effect of the traffic is that it's not going to get slowed down as much because it only has to go through one resistor in place of 2. And so mathematically, when I solve this, the equation, if you have your resistors hooked in parallel, is 1 over the effective resistance equals 1 over resistance 1 plus 1 over resistance 2 plus however many resistances you're going to have there. So if I'm going to go to solve for this one, 1 over the effective resistance equals 1 over 12 ohms plus 1 over 15 ohms. Now, the easiest way to do this on your calculator may give you a slightly different result than the answer that he gets in the book, and I'm okay with that. So here's the way I would recommend that you actually type this into your calculator. You have a button on your calculator that's going to look something like this, where it's a reciprocal button, a 1/, button. And so what I would do when I solve this problem is this. I would type in 12, and then I would hit that button and make it a reciprocal. Plus, then you're going to type in 15 and hit that button again and make that a reciprocal. Equals, and then when you get, the answer that you get is going to look like this. So you're going to hit the 1/, button one more time to flip it upside down. And then you're going to be able to do these problems all in one step. Now, the difference that you will get is in the number of significant figures, because when he flips these individually and turns them into a decimal, he worries about significant figures at each point in that decimal. And then when you start adding those decimals together, that affects number of significant figures. I'm perfectly okay if you just do it the way I told you and you say, okay, well, this has 2 significant figures, this has 2 significant figures, my final answer is going to have 2 significant figures. Now, I will warn you, you might get into college, and if you're taking an E&M course in college, the professor might go, well, I don't know what your high school teacher told you, but you can't do it that way here. So I'm just going to warn you that that might possibly happen. But for our purposes, calculating this way is easier, it's quicker, and for what we're going to be doing, it's perfectly acceptable. So when you do this, you are going to end up with an effective resistance of 6.7 ohms. Okay? So again, you're going to hit 12, hit the reciprocal button, plus 15, hit the reciprocal button, equals, and then you're going to hit the reciprocal button one more time, and you should end up with that. So make sure that you get your calculator out, you actually try that, and you make sure that you get the same answer. Then when you're checking your homework problems, be aware that the significant figures may be off a little bit. It shouldn't be very far, but it may be off just a tad bit, so don't let that concern you.